By now, we know that the definition of a chemical reaction is the breaking and forming of new bonds between atoms and molecules. What we'll now focus on is how we can classify chemical reactions. For now, there are 7 classifications you should be familiar with, so let's go through each. Starting off, we have a synthesis reaction. A synthesis reaction is when 2 or more reactants combine to form a single product. The important thing to remember about synthesis reactions is that you're only forming one product. In general terms, you can think of synthesis reactions as reactant A and reactant B coming together to form the new product C. An example of a synthesis reaction is the formation of water, shown by 2 moles of hydrogen gas plus 1 mole of oxygen gas combined to form 2 moles of water. Again, we're taking 2 different reactants and forming a single product. Decomposition reactions are like the opposite of synthesis reactions. Here, a single compound is being broken down into 2 or more simpler substances. Decomposition reactions can be shown by the general equation AB is breaking down to form A and B. Although A and B split up perfectly in this representation, don't let that confuse you. Remember, the definition is just a single compound being broken down into 2 or more simpler compounds. So even though the equation for the decomposition of hydrogen peroxide isn't as simple as our AB decomposition reaction, it still shows a decomposition taking place. In a single replacement reaction, one element is replacing another in a compound. This can be shown by the equation A plus BC, our reactants, form AC and B, our products. The important thing to remember about a single replacement reaction is that it is, again, talking about a single replacement. So in our equation below, A should be the only element replacing something, and C should be the only element being replaced. An example of a single replacement reaction is zinc plus hydrochloric acid will react to form zinc 2 chloride and hydrogen gas. Notice that the only thing that's replacing something is zinc. Zinc is replacing our hydrogen. And the only thing that's being replaced is our hydrogen. So again, this is a single replacement reaction. And so a double replacement reaction is exactly what you would expect. Now, instead of a singular swap happening, ions in 2 compounds are swapping with one another to form 2 new compounds. This can be represented by the equation below. As you'll notice, our A and our C ions are being held constant, right? Those are in the same locations in both the reactant and product side of the equation. However, our B and D ions, those are the ones that are moving around. Our B was originally with A, but in our product side, it is now with C. And while D was originally with C, it is now with A on the product side. And so again, the important thing to remember about this is that we are doing 2 full swaps. An example of a double replacement reaction is the combination of silver nitrate and sodium chloride to precipitate out silver chloride and sodium nitrate. And so as you can see, our nitrate and our chlorine, those are our 2 ions. They are swapping with one another and going to form 2 new compounds. Combustion reactions are everyone's favorite, and that's because it's the reaction which takes place when you burn or blow something up. The technical definition for a combustion reaction is a rapid reaction between a combustible substance and an oxidizer, which in most cases is going to be oxygen. In AP Chemistry, you'll mainly be looking at combustion reactions involving hydrocarbons. Hydrocarbons are organic compounds existing exclusively of hydrogen and carbon. When we combust a hydrocarbon with oxygen, our reaction always produces carbon dioxide and water. Thus, we can write the general form for a combustion reaction including hydrocarbons as our hydrocarbon plus oxygen gas reacting to form carbon dioxide and water. An example of a combustion reaction is the combustion of methane in the presence of oxygen, denoted by methane plus oxygen gas will react to form carbon dioxide and water. Again, remember that these reactions involving a hydrocarbon will always produce both water and carbon dioxide. An acid-base reaction is when an acid reacts with a base to form a salt and water. You know acid as the flesh-decomposing liquid, but of course the real definition is going to be slightly more professional. An acid is classified as a molecule which, in a reaction, donates a single hydrogen proton to another compound. Therefore, acids can also be referred to as proton donors. Bases are going to be the opposite of that. A base is a molecule which, in a chemical reaction, accepts a hydrogen proton. That's why bases can also be referred to as proton acceptors. The general form for an acid-base reaction is our acid reacts with our base to form salt and water. An example of an acid-base reaction is hydrochloric acid reacting with sodium hydroxide to form sodium chloride and water. As you can see, our HCl is going to dissociate into the hydrogen proton and chlorine ion. It's going to give up this proton, therefore HCl is our proton donor, or our acid. Sodium hydroxide is also dissociating into the sodium and the hydroxide ion. This hydroxide ion is going to pick up a proton and become water. Therefore, we can say that our sodium hydroxide is our proton acceptor, or our base. And then of course sodium chloride is a salt, and water is water. The very last reaction you need to know is a redox reaction, also known as an oxidation-reduction reaction. These involve the transfer of electrons between molecules, and can be seen in batteries or even the formation of rust. Oxidation is the loss of electrons, and reduction is the gaining of electrons. You can remember this with the acronym OIL-RIG, which stands for oxidation is lost, reduction is gained. Oxidation means we're losing electrons, reduction means we're gaining electrons. An example of a redox reaction is 2 sodium atoms plus chlorine gas reacting to form 2 moles of sodium chloride. Sodium and chlorine initially start with a neutral charge. When sodium and chlorine form the ionic bond to form sodium chloride, they each become ions. Sodium becomes the positive sodium cation, and chlorine becomes the negative sodium anion. So if sodium is losing an electron, we would say that sodium is oxidized. If chlorine is gaining an electron, we would say that chlorine is reduced. Again, oxidation is lost, reduction is gained. And so those are the 7 classifications for reactions which you need to be familiar with in AP Chemistry. The reason behind all of this is that if a reaction can be classified, it'll be easier to predict its products, write its net ionic equation, and explain how its reactants and products are affected and related to one another. And with that being said, that's all you have to know over the types of chemical reactions for AP Chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.